Now the third example is, that is a very important example. We can differentiate sine of tan inverse x. If the inverse function is including in a trigonometrical ratio, so we can let them is theta. So let tan inverse x is theta, taking the tan inverse from here, so we get x equals to tan theta and x upon 1. So tan theta know that perpendicular by base, so you can write that p by b. So the perpendicular value is x and base value is 1. So we can make our perpendicular x and base is 1 by using the Pythagoras. We get the value of hypotenuse is root over 1 plus x square. Okay, now the cos theta is based upon hypotenuse, base is 1 and hypo is root over 1 plus x square. So we get the result of cos theta is 1 upon root 1 plus x square. Why we calculating it? We can discuss about an answer. So we can assuming it again, tan inverse x is theta. So that is the solution part again. Tan inverse x assuming it theta. So differentiation of d by dx of sine theta. Here we using the chain rule. Differentiation of sine theta is cos theta and d by dx of x. In place of x is theta. So we can assuming it here the variable is theta and the value of theta is tan inverse x. So we get cos theta. Why we are calculating here the cos theta? Because we have to put the value of cos theta in terms of x. That's why we are making a triangle and by using the Pythagoras and get the value of cos theta. 1 upon under root 1 plus x square. Put here the cos theta root over this and theta is tan inverse x and differentiation of x with respect to x is 1 upon 1 plus x square by the formula of tan inverse x. So finally we got the answer. And that is the half, that is 1. Adding all these power, we are getting 1 upon 1 plus x square, 3 by 2, that is the answer. Next example, we have y is equals to sine of 2 sine inverse x. Then prove that d by dx equals to 2 root 1 minus y square upon 1 minus x square. How we can differentiate it? We are taking the sine inverse x both these sides, because in that form we can differentiate, so we don't get the result of proving d by dx is that. That's why we are taking the sine inverse both these sides. That sign transfer from here is the inverse reciprocal of it. We get sine inverse y equals to 2 sine inverse x. That is the remaining term. Now we can differentiate with respect to x. So the differential of sine inverse y is 1 upon root 1 minus y square. In place of x we have a y. So by using the chain rule we are getting here 1 upon root 1 minus y square and d by dx of x value of x is y. So we put here 2 derivative of sine inverse x directly root 1 upon 1 minus x square. That is the formula. So we get the d by dx by cross multiplying of it. We get root over 1 minus y square upon 1 minus x square. That is the answer.